The AI agent made 60,000 decisions. Months later, an auditor selected one customer outcome and asked a simple question: can you show exactly what the agent saw, which model and policy it used, who authorized the action, and what happened next? The team had saved the final status. Everything else had moved on. The input record was overwritten, the model was replaced, and the policy file had changed. Not one historical decision could be reconstructed with evidence. This is an illustrative scenario, not a reported incident. The agent can generate a convincing explanation today, but that explanation describes current logic. It does not prove what happened then. Explainability helps people understand a decision. Auditability preserves a reliable historical record so an independent reviewer can trace the decision from inputs to outcome without trusting a story written after the fact. The NIST AI risk management framework is voluntary and use case agnostic. Its core emphasizes sufficient documentation, traceable measurement, and documented test, evaluation, verification, and validation. As a regulatory example, Article 12 of the European Union AI Act addresses automatic event logging for applicable high-risk AI systems. The operational lesson is broader: decide what evidence your risk, oversight, and legal context requires before the first production decision. Build the autopilot in 6 parts. First, define one decision record schema. Give every decision a unique event identifier. Capture the business purpose, system, and agent identity, request time, relevant inputs, output, confidence or reason codes where meaningful, downstream action, and final status. Link rather than copy sensitive data when possible. The schema should distinguish source evidence from annotations created later. Second, bind the decision to exact versions. Record hashes or immutable references for the input snapshot, model, prompt, policy, retrieval source, tools, configuration, thresholds, runtime, and deployment package. Where randomness affects replay, preserve the relevant seed and settings. A version label is useful only if the underlying artifact can still be retrieved and verified. Third, capture authority and execution. Record which human or service delegated access, the scope and expiry of that authority, approvals, overrides, tool calls, external responses, timestamps, retries, and downstream rights. Build a continuous evidence chain from intent to action. If a tool response changes, preserve the response that the agent actually received, not the value available today. Fourth, protect integrity and retention. Store records in append-only or tamper-evident form, sign, or hash evidence bundles, separate operational writers from audit readers, log every access, and test restoration from backup. Set retention by decision type, harm window, investigation needs, privacy obligations, and applicable law. Keep enough evidence to investigate, but do not turn auditability into unlimited data collection. Fifth, run independent reconstruction tests. Sample decisions across risk levels, time periods, models, and edge cases. A reviewer should retrieve the exact evidence bundle, verify its integrity, rebuild the decision path, and reconcile the recorded downstream action. For non-deterministic systems, the goal may be to reconstruct the historical basis and execution chain rather than force an identical new output. Missing evidence, broken hashes, or an unexplained downstream mismatch becomes a control failure. Sixth, connect evidence quality to release and monitoring gates. Before deployment, verify that every required field is captured and retrievable. In production, monitor missing records, delayed logs, orphan tool calls, version gaps, retention failures, unauthorized access, and failed reconstruction samples. Block a risky release when the evidence chain is incomplete. Open an incident when an already live chain breaks. Now replay the audit. The selected decision has one sealed event identifier. Its historical input snapshot, model, policy, authority, tool calls, approvals, timestamps, outcome, and downstream write are all linked and integrity checked. An independent reviewer reconstructs the chain end-to-end and records the test result. The organization no longer asks the current agent to remember the past. It produces the evidence. That is the AI agent decision auditability autopilot. Define the record, bind the versions, capture authority and execution, protect retention, test reconstruction, and gate on evidence quality. A plausible explanation is a story. An audit trail proves what happened.